Hello and welcome to the Table M indicator notes. What we're talking about today is a way that we can measure pH. pH can be measured exactly with something called a pH meter, but very frequently pH meters can be a little bit fragile, or you might not have one where you are. In our classroom we don't, so we'll be using an indicator solution. Indicator solutions are solutions which change color by gaining or losing a proton. They're actually a chemical equilibrium where hydrogen ions can pop on and off, and that will actually create a color change. You can actually relate this to if you ever talked about the flowers that grow different colors and they're in different colors of soil, cabbage juice indicator, that kind of stuff, all function biologically, but by the same method. Table M contains our indicators, and so you're going to want to flip to Table M right now. Reference Table M shows you what color change you will have during particular pH ranges for specific indicators. This table can be a little bit confusing to students because of this pH change range. What this really means is if you were to take methyl orange, for example, methyl orange is red, for sure, below a pH of 3.1. It is yellow, for sure, above a pH of 4.4. In this middle range right here, it could be red or yellow. And I know that's a little bit confusing, but if I were to tell you that I had a substance that turned methyl orange yellow, really the pH could be anything above 3.1. If you wanted to find out a little bit more details, you would pick another indicator to use. Like you might use bromethymol blue to see if it was yellow or blue, and that might give you a little bit more information there. We're actually going to be doing that in lab tomorrow. So what you should be able to do using this table is figure out basic pH ranges and answer some simple questions. So if we look at bromethymol blue changes between 6.0, oops, let me get that black, pH of 6.0 to 7.6. Anything less than 6, for sure, will be yellow. Anything greater than 7.6 for sure will be blue. Within that range, we're not really sure. The litmus change range is 4.5 to 8.3. Anything at a very low pH before 4.5 will be red, or below 4.5. Anything greater than 8.3 will be blue. For sure, guaranteed. So I took a solution here. You can see these little clear dots right here. Those are actually something called a buffer solution. This is a solution of known pH. And then I went ahead and I added indicator to each of those. So hopefully you can see these colors okay. We're actually going to be doing this in lab tomorrow. There are some things that are a little bit tricky in terms of making a judgment call. For example, you might look at this methyl orange and be like, well, that looks like an orange dot to me. But we have to decide if we think it's more red or more yellow. And when you sample a few different, when you look at a few different samples, you'll see that the red for this is truly red. So I would say for sure that this would be considered yellow. My bromethymol blue is definitely blue. Again, these are a little bit easier to see. I apologize, there's a little shadow on here. Phenolphthalein can be either colorless or pink. We see a light pink color there. My litmus is blue. Again, these will be much clearer in person. My picture did not come out as good as I thought it might. My thymol blue is kind of a tough call. I think it's a little bit of a green color almost, but thymol blue has to be really either yellow or blue. I'm going to go with calling this, that's still kind of tough. I might actually, for right now, call this green. We'll talk about that in a minute. My brome cresol green is for sure a nice blue color. Now, what this tells me is methyl orange is indicating that the solution has to have a pH of greater than 3.1. Could be, it's probably greater than 4.4, but we don't know. My bromethymol blue is indicating that I have to have a pH greater than 6.0. My phenolphthalein is indicating that I have to have a pH greater than 8. My litmus is indicating that I have to have a pH greater than 4.5. The thymol blue is one that's a little bit tricky, okay? So I'm going to talk about why this is tricky in a minute. And then my Brome Cresol Green has that nice blue color, which indicates that this is somewhere of a pH of over 3.8. Now, the really important result here are the ones that make things a little bit more specific. So we know, based on this, that our pH has to be greater than 8. So it's obviously greater than 3.1, obviously greater than 6, obviously greater than 4.5, obviously greater than 3.8. So it's kind of helpful actually right now to look at our thymol blue sample because you see that kind of weird green color. So you might be like, well, why isn't it clearly yellow or clearly blue? The pH of this solution that I used is actually 8. So you can see for thymol blue that that falls kind of right in that change range. So if I were asking you, based on this information, to tell me a pH range for this solution, the range that you would probably tell me based on your data should probably be somewhere between 8.0 to 9.6. With indicators, we really can't get an exact value. We do have a universal indicator, which can give us a little bit more information, and we will use that a little bit in class. This is what we're going to be doing in lab tomorrow, so you'll actually get to see a bunch of these indicators and kind of get a little practice with table M. Here's some sample questions for you. You can pause the video for a moment and try them out, and then I'll put the answers up. So number 1 is Brome thymol blue. Brome Cresol Green changes below the range that we needed to change. Litmus goes red to blue, red to yellow for methyl orange, so Brome thymol blue is our answer. Our indicator that's going to be blue in 5.6 is going to be Brome Cresol Green. Brome thymol blue will be yellow. Methyl orange is never blue. Thymol blue would be yellow at that particular pH also. Next one is a kind of a Regents pH style question. We have an aqueous solution changing from 4 to 3 when my hydrogen ion concentration does what? So I'm not sure if we'll have covered this in class yet or not. pH is by factors of 10. So we know that our pH has changed by a factor of 10 because it went 1 unit. And because our pH went down, this tells us we had an increase in hydrogen ion concentration. And the last one, we've got some indicator information there. The fact that methyl orange is yellow tells me that at the very, very least, my very least possible pH is going to be 3.1. Based on litmus, my very, very lowest pH possible, since it's going to be red, I'm sorry, I meant to say my very highest pH. So my very highest pH possible, because it's red, is 8.3. So my pH would need to be somewhere between those numbers. So tomorrow in class, we'll get a little bit more practice with using table M in a lab setting.